Howdy CNC fans. For something totally different than you normally see me carve, I had a request recently to make a set of spinning cornhole boards based upon Matthew Peach's design here. The client asked for two changes. One, could we remove the 2x4 that appears to block the hole so the bags drop through properly? And two, is there a better way to support the spinning mechanism? After researching it a bit, I ran across this, a Lazy Susan, available on Amazon, that I think answers both the requests. There are hundreds of other YouTube videos on how to build cornhole boards. This will not be the complete build, but instead focus only on how I installed the spinning mechanism. After several prototypes, here it is in Vectric V-carve with all the cuts that need to happen. Remember, this is the under side of the board that you're cutting, and I'll make the files available in the description link below. And let's get started on the CNC. The first job I have it cutting is the slots for the bag storage. Then the next thing you'll see here with a 1/4" bit, it's cutting the pocket holes for the idler arm assembly. This is where we're going to put in some threaded inserts. And this is the groove that it's carving right now where the rod moves back and forth for the idler arm. Then it switches over to an 1/8" bit, and I cut the 6" circle in the middle first. And after it carves enough passes through to carve that through, then it switches over same 1/8" bit to carve the outer ring that fits the 16" Lazy Susan. Once all the carving's done, zip in 3 1/4x20 threaded inserts. That'll be where the idler arm mounts. Then take it off the CNC. Go ahead and cut all the tabs loose. And after the tabs are all cut loose, then you can proceed to do all the roundovers on the inside and the outside edges. As an optional step, if you'd like to add some branding to the things you create, I found this step from another YouTuber. It works really, really well. Using a flute job with the CNC, just run some small grooves, come back, fill it in with some Star Bond, hit it with an activator, sand it off, and you end up with a really nice high quality logo that's never going to fade or never going to go away. The next thing we're going to cut is using a 2x4 sheet of 3/4" MDF using a 1/2" 90-degree V-pit. And this is cutting the drive rings that when two of them are clamped and glued together will create the V-pulley that the belt will ride on. So it's going to cut 4 of these. The reason we picked a 16" Lazy Susan is 4 of these fit on a single 2x4 sheet. And then the next bit it runs as I use that same 1/8" end mill to cut the 4 pieces out of the material. I will include a link to download the V-carve file for these drive rings as well in the description. Next, we're going to assemble the 2 halves of the MDF cutouts that create the V-pulley. So here we're going to glue it together and screw it together. Take care here to ensure that the inner and outer holes align exactly. Otherwise, your circle will be out of round and it will create some issues. Once you have the inner and outer circles perfectly aligned, use some clamps to hold it in place before you screw it down. Otherwise, with the glue, it will have a tendency to slide around. And lastly, use a wet rag to clean up any excess glue that's in the V-groove. And with that, your V-pulleys are fully assembled and ready to be installed on the board. Pictured here are all the parts I used to create this set of cornhole boards. I will include a link in the description to each and every part available on Amazon. Let's start with the Lazy Susan install. First, remove the rubber feet. They aren't used at all. Then, on the outer ring, those holes need to be drilled all the way through. But wait! Learn from the mistake that I made on the very first Lazy Susan that I drilled out. When I drilled, aluminum shavings got into the seam and basically ruined the Lazy Susan. So take your time, mask off the seam so shavings don't get in there. And now you can drill through the outer ring with a 3/16 drill bit, followed by a countersink bit so the screws sit flush. Next, let's attach the spinning portion of the board to the Lazy Susan. Take your time and make sure the wood is perfectly centered on the Lazy Susan. If it isn't centered properly, it could rub on the outer edge of the board. Then clamp it to ensure that it doesn't move, screw it in place, and you're ready for the next step. Now we're going to attach the Lazy Susan to the main part of the board. And the easiest way to do this and ensure that you have your 1/8 inch gap all the way around is I have, for instance, this piece of 1/8 inch thick PVC plastic that I just ensure that the gap stays consistent, and then go ahead and screw the bottom together. Next, let's assemble and install the idler arm. The 3 bolts on the right you don't need, you can throw those away. You may need to drill out those 3 holes with a 1/4 inch drill bit indicated on the right. Then just complete the assembly as per the picture on the right. When tightening the bolt for the arm, tighten it snug, but ensure that it can still pivot properly. And when tightening this bolt as well, ensure that the roller still spins freely. And finally attach the spring. I usually attach it to the middle hole. That's about the right amount of tension. I start by placing some 1/4" washers over the threaded inserts. That gives the spring just a little room above the board so it pivots properly. Then go ahead and install the 3/4" long 1/4x20 bolts into the threaded inserts and go ahead and tighten them down. Lastly, test to ensure that the idler arm swings freely. Alright, let's assemble the pulley, the motor mount, and the motor. Again, all of these items will have a link in the description below. In my testing, I tried a number of different motors. Some of them as low as 15 RPM, some as high as 110, anywhere in between. This one's 60 RPM. That seems to be the sweet spot. There isn't a lot of room at the back of the motor mount for the bolt, so I found using the needle nose pliers helps you get it started, and then you can go ahead and tighten it down. Then let's attach the pulley to the shaft. The large end should be away from the motor, and make sure that it's flush with the end of the shaft. That should be about the right height, and then tighten it with the supplied Allen wrench. There are 2 Allen set screws to tighten. This next step is purely optional. One of the things I did was cut down the shaft about a 1/2 inch and the lower half of the pulley, thereby reducing the overall height, and it fits flush with the bottom of the board. Now let's install the drive ring to the bottom of the board. Take your time ensuring that the 6-inch hole lines up perfectly, then go ahead and screw it down. We're going to bypass the side rail install and the storage box install and go right to the belt and motor install. I have found it easier to install the motor by removing the idler arm first and then reinstalling it afterwards. Start by placing the pulley around the drive ring, then slip it over the pulley on the motor. Pull tight, pull as tight as you can, and then screw the motor to the side wall, ensuring that the pulley is level and straight. The motor should be installed away from the top to leave yourself clearance for the leg. Then slip the idler arm back under the pulley, attaching the first 1/4" bolt back into the threaded insert. Make sure your spacers are still there. Go ahead and tighten that first one down, and then get the other 2. Next, let's install some strain relief on the power cord so no one pulls it out of the motor. And let's give it a test. Here we go. Here's a view of the storage box that holds the bags and the power cord. That was the two grooves we carved early on in the video. This build request was to have it run off of AC, but I wanted to see if I could have it run from a cordless tool battery. So what I got was a Power Wheels Makita battery adapter, 18 to 12 volt transformer, and a 400 watt inverter. And as you can see, you plug in the battery to the adapter, plug it into the inverter, and there it goes, it runs. In my testing, that Makita 5 amp hour battery ran this board for a little over 4 hours. If you did want to make this a cordless version of the board, you can see there's plenty of room to mount those components down below. I tested several inverters. I recommended a 400 watt minimum. To find the adapter that fits your cordless tool batteries, just go to Amazon, search for Power Wheel Adapter. Cobalt, Makita, Milwaukee, DeWalt, they're all available. I tested several different brand cordless tool batteries from friends and neighbors, and they all worked just fine. I will add the inverter part number and the transformer part number as options in the description. This next step is a little out of sequence. The motor that you get does not come with a power cord, so you have to supply your own. Typically you can get an old computer, old monitor, old appliance, snip the end off that went to the old computer, strip them about 1.5 inches back, and separate them, get them ready to install. On the green ground wire, I strip that and attach a ring so that I can mount it to one of the bolts on the motor. Here's a close-up of the completed wiring on the motor. As you can see, the O-ring is mounted to the steel stud. The black wire always goes to the center. That is the hot wire. The white wire goes to the left. It'll spin clockwise. If you put the white wire on the right, it'll spin counterclockwise. Here's the completed build, less the vinyl wrap, which I'll add after this. But I wanted to just show you how much weight it can handle and just keep running. And here it is in play, running off the Makita cordless battery. And that's all there is. I'll apply the vinyl wrap finish, ship it out to the client, and you're all good to go. Enjoy!